let us understand the combustion of alkanes. We understood about substitution reaction. Now let us understand the process of combustion. What is combustion? Combustion is the process of burning in presence of air, which will release enormous amount of heat and energy. Next, here let us take up the example of methane. Methane is subjected to the process of combustion, that is burning in presence of oxygen of the air. So it will always result in the formation of carbon dioxide and water. It will release water along with the liberation of carbon dioxide. Now let us see if this is a balanced equation. So we have 4H there and only 2H. So therefore let us introduce this 2 in front of H2O. So that will be 4 hydrogen, and what is that we are still left with here? 2 oxygen, and then 2 oxygen, that makes 4 oxygen. So let us introduce the 2 coefficient in front of oxygen. So now this is a balanced equation of combustion reaction of methane. Methane gas, when subjected to the process of combustion, will form carbon dioxide gas, liberating the carbon dioxide gas along with formation of H2. Now, how to write the complete combustion reaction, balanced chemical reaction for the alkanes? We have a simple formula that will help us. CnH2n plus 2 is the general formula of alkanes, plus 3n plus 1 divided by 2. So many molecules of oxygen need to be taken. When we do that, it will give us n molecules of CO2 and n plus 1 number of molecules of H2O liquid. CO2, of course, gas. Oxygen is gas. So now let us try out an example for this. Say supposing we want to write the equation, balanced chemical equation for combustion of, let us say, butane. So C4H10 is the molecular formula of butane. So how many carbon atoms are there in butane? 4. So when we apply that in this formula, 4, 3 into 4, because n is to be replaced by 4. N indicates the number of carbon atom, plus 1 divided by 2, that many number of oxygen molecule or dioxygen gas to be considered. So how much would that be? 3 4s are 12 plus 1 13, so 13 by 2. So balanced equation would be C4H10 plus 13 by 2 O2 gas. So this is on our LHS. So let us see on our RHS. What would be our RHS? So let us apply the formula NCO2. So N number of CO2 would be released. That N here is 4. It indicates the number of carbon atoms. So in this case N would be 4. So we will end up in the formation of 4 molecules of CO2 gas along with N plus 1. So N again to be replaced by 4, because 4 number of carbon atoms, plus 1 5. So 5 H2O liquid. So therefore the balanced chemical equation would be, for the combustion of butane, C4H10 plus 13 by 2 O2 gas gives us 4 CO2 gas and 5 H2O liquid. Let us see if it is balanced. So 4 carbon atoms here, 4 there on our RHS also. So 13 by 2. So therefore that's also balanced there. So this is how we get a balanced chemical equation by applying the formula.